Okay, percentage yield. The percentage yield is very important in chemistry because often you're trying to make a particular product and you want to know how much of that product you've made. And the only way you can do that is you can work out how much you should have made, so the theoretical amount that you should have made using formulae and equations, and then find out how much you did make. And obviously, if you're in industry, you want a high percentage yield. So you want your reactants to make as much of your product as possible and no waste. Okay, so the percentage yield is a measure of how much you've obtained of a particular product in an experiment. The formula, nice and simple. Percentage yield is the actual yield, so how much you do get, by the theoretical yield, how much you should get, times by 100%. Let's look at an example. So we're making copper sulfate crystals and we used 4 grams of copper oxide and excess sulfuric acid. Okay, 4 grams of copper oxide, excess sulfuric acid. 4.5 grams of the crystals were obtained. Okay, so this is my actual yield. That goes in the numerator there. That's how much I got. But I need to work out how much I should have got. So I've got to use my formulae and my equations. First, we write the equation. Have a go writing the equation. Stop me if you need to. It's copper oxide, copper 2 oxide plus sulfuric acid. Okay, and it looks like that. And then we use reactant masses to work out how much we should have got. So according to this, 80 grams of copper. Where did I get the 80 from? Well, this is theoretically, this is how much mass 1 mole of copper 2 oxide has, isn't it? So copper is 64 on your periodic table. Oxygen is 16. 64 plus 16, 80. It should make 160 grams. Again, add this all up. Copper 64, sulfur 32, oxygen 4 times 16. 4 times 16 is also 64. 64 and 64 is 128 plus 32 is 160. We're not worried about how much mass of these we would have. Basically, 80 grams of this would make 160 grams of this. But I didn't start with 80 grams. I started with 4 grams. Okay, 4 grams were used. So I should get X. We need to work out the theoretical yield. Well, you can see the simple relationship that X is going to be this times this divided by this. X is going to be 8 grams. So my theoretical yield is 8 grams. That will go in my denominator. We'll do the calculation, percentage yield. It's 4.5, the actual yield divided by the theoretical yield times 100, 56.25%. Okay, that's percentage yield. Percentage purity is also very important in chemistry, especially if you're making medicine, drugs, etc. Okay, so we need to know how much of the pure substance that we've made is in our product, the percentage purity. But typically, if you've got a paracetamol tablet, not all of it is paracetamol. So you need the percentage of paracetamol in that tablet. The equation is very similar. It's the mass of the pure substance divided by the total mass of the sample times by 100%. So imagine I've got a sample of 22 grams of ibuprofen and it was found to contain 18.5 grams of pure ibuprofen. So obviously there's other things that they put in tablets. It has 18.5 grams of pure substance. The percentage purity is 18.5, the mass of the pure substance, divided by 22, the total mass of the sample, times by 100%, and that gives me 84.1% purity. That's relatively straightforward too. Okay, right. We've got some pages in the book for you to read and some questions to answer, and also we've finished the chapter so you can try the end of chapter questions.